Hello, welcome to everyone in this lecture. This is the part 4 of the measurement of the microwave and lecture 12 in this series. And in this lecture, we actually cover up this portion, that is the measurement of the microstrip line parameter. Okay, you can look at the syllabus of the 4th semester University of Calcutta for the advanced paper, that is the microwave. You can watch the previous one that is already covered up. This transmission line and waveguide component already covered, and finally in the measurement part, in the first part we covered this one, in the second part we covered this portion, in the third part we covered this portion, and this is the fourth part we wants to discuss about the measurement of the microstrip line parameter. In the next class we will be covered and so on, right? So let's start with this, and this is the recommended book, you can refer to this one. You remember in the first class, that is the in the transmission line and waveguide, there was a microstrip lines and their characteristic impedance, so on. So we already discussed about the microstrip line, that is there was a conductor in this lower side, and in the upper side there is a strip conductor, and their dimension was my micrometer. That's why this is called the microstrip line, right? And the if you want to see the electric field lines, through this dielectric, this is dielectric, and this is through this air, and then dielectric, right? So this is the schematic diagram of a microstrip conductor to transmit the microwave, and you have know about the different advantage of microstrip lines we already discussed in this section. Okay, and you can see this is the field lines, which are these are the electric field line, and these dotted are the magnetic field line, because you know the electric field and magnetic field are perpendicular to each other. And in that lecture we actually find out these characteristics impedance of this microstrip line for the narrow microstrip line, this expression, and for the for the wide microstrip line, this was the expression, right? Where you can see this is the h, and this was the w width of this microstrip, and T is the thickness of this microstrip, and so on, right? So we already discussed about this. These are the characteristic impedance of this microstrip, right? From this characteristics impedance from this characteristics impedance from this characteristic impedance, we can find out the reflection coefficient, because the reflection coefficient is reflected by the incident part, and the return loss. In the last video we discussed about the return loss and the standard wave ratio. These are this expression. So this can be calculated from these expressions, and this instrument, that is impedance analyzer or network analyzer, is to determine these values. Actually these values can be determined using this instrument, right? And the graphical presentation, that is mixture, also used for the to finding this value. So in case of microstrip line, we can find out this reflection coefficient, or return loss, or the standing wave ratio. Return loss and inertial loss are related, so we can find out only one is enough. So this instrument can be used as to determine for this, and 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 this reflection loss is z minus z0 by z plus z0, this expression already discussed, right? And this normalized impedance is z by z0. This is the in terms of reflection coefficient of the normalized impedance, right? So this total expression, this is the mathematical expression, this can be find in this instrument, that is the analyzer, impedance analyzer, or you can say network analyzer, right? So in the other terms, you can determine this s parameter. Remember this scattering parameter, that is the if you take the two port network, that is that only input and output out to two port consideration, then you can take these are four constant a1 a2 a1 a2 b1 b2, So the S parameter can be written as here, and this S R defined is like that because you take this as a combination. So S11 will be B1 by A1 when A2 is 0. B1 by A1 and A2 is 0. Since the traveling load the totally absorbed B2 is 0 means there is no transmission. You can see here there is A1, A2, B1, B2. I think you remember this diagram, that is A1, A2, B1 reflected part and B2 reflected part, right? That, so you can see here this S1 was nothing but B1 by A1, A2 is 0. A2 0 means there is no transmission in this network. There is no transmission in this network, right? So it is a traveling wave of incident load will be totally absorbed. And in the similar fashion you get the S22 and so on. So this scattering parameter we discussed in the lecture, so previous lecture. So this parameter can be expressed. And finally, if you think the how we can measure this parameter, that is using this network analyzer. So at first you need to calibrate this network analyzer and then determine the transmission and reflection coefficient of this filter. So using this network parameter you can find easily this reflection coefficient, transmission coefficient, and all about this. So this is the same pattern or measurement can be happen in the previously we obtained. Just one thing is remember, there is the basic difference for the narrow microstrip and for wide microstrip. This Z0 is changes, and the Z0 change means the gamma reflection coefficient also change and the corresponding value will be changed. So the mathematics will be changed, but the instrumental process will be the remain same. In case of the other dielectric material property we already measured the because in the previous lecture we discussed about this dielectric material and their property and their AC conductivity, dielectric constant, losses, all are calculated. So using these things, that is the that these dielectric are actually used in these microstrip lines, and you know there is a lot of advantage of microstrip lines. So that's why we actually discussed this portion for the calculating the losses within this system. So this was the another method to transmit the microwave, and the loss can be calculated by this instrument. So at first calculate this one and then finding this reflection coefficient, and then find the design the microstrip line and measure the microstrip line. So this is the total process to get the values of in case of microstrip, and by which we can use this microwave for an appropriate purpose, right? So that's it for this portion. In the next class we will be discuss about this that is the source. Okay, so we covered this portion, transmission line and waveguide component and measurement. In the next class we will be continue to the source, okay, and then antenna, and then microwave integrated circuit. So that's it for today. So we'll meet in the next class as soon as possible. So this is all about me. This is my contact details and this is my YouTube channel details. So take care. We'll meet in the next video as soon as possible. Thank you.